Welcome, everyone. I'm Kerry Schrantz, and on behalf of the School of Business and Wake Forest Executive Education, thank you for joining us for today's webinar. As everyone is aware, we now live in an age of data. Through the use of computers, cell phones, and other smart devices, we generate enormous amounts of data that companies can use to better understand customers, track products, more effectively utilize resources, and increase productivity and the bottom line. The data analytics lifestyle substantively impacts decision-making in areas such as marketing, financial forecasting, operations, and systems and IT. Understanding descriptive, predictive, and prescriptive analytics capabilities allow us to take advantage of unforeseen opportunities and analyze risk critical to the vibrancy of most organizations. For the next 45 minutes or so, Dr. Jeff Kam will offer a fresh look at the current trends in analytics, provide an overview of data visualization best practices, and close with perspectives on the certificate in analytics for analysts. Just a little housekeeping before we get started. Everyone's audio has been muted. If you have any questions during the presentation, please submit them to me in the chat box on your Zoom control panel. Jeff will have time for questions at the end of the presentation, and he'll address as many as possible. Today's webinar will be recorded, a copy of which will be forwarded to you in the next few days. I'd also like to acknowledge my colleague, Whitney Strickler, who will be assisting in today's webinar and providing post-presentation follow-up. As mentioned a few moments ago, our presenter today is Dr. Jeff Kam. Jeff is Associate Dean of Business Analytics at the Wake Forest School of Business, where he leads the on-ground and online MSBA programs. His academic scholarship focus are on the application of optimization modeling to difficult decision problems in a diverse set of areas that include operations and planning, scheduling, supply chain optimization, product design, and conservation. Jeff is also the co-author of 7 books on business statistics, management science, and business analytics, and his research has been featured in numerous academic journals. Outside of academia, he has led consulting engagements with the likes of Procter & Gamble, Owens Corning, GE, and Kroger. I'm now going to go ahead and turn things over to Jeff.
Thanks, Kerry. Can everyone hear me okay? Can I get a thumbs up from somebody? Yeah, excellent. Thank you, Raleigh. Good to be with you all this morning. Thanks for being here, and thanks, Kerry and Whitney, for inviting me. So, as Kerry said, I'm gonna begin with a little bit of an overview of analytics before we dive into more of a focus on data visualization. And I always like to start with a definition of analytics because it can mean a lot of different things to people. It can be a very broad term. Some people would say it's as broad as science, for example, but here's a definition from the Professional Society Informs that I've adopted and one that we've used in our textbooks. The scientific process of transforming data into insights for making better decisions. And so I typically contrast analytics and data science, where I say analytics is problem focused or decision focused, and data science tends to be a little bit more data focused. At the end of the day, we're all trying to help people make better decisions. And as Kerry mentioned, we talk about descriptive, predictive, and prescriptive analytics. And today we're going to focus on an aspect of descriptive analytics, which is data visualization. But all three of those sort of work in tandem to help people really solve business problems. So I thought I'd start with a little bit of an overview of what's going on in the analytics space right now. And so there's a wonderful piece of software that's from this company, Burning Glass. And Burning Glass keeps track of job ads in all different fields, and they have this huge database. For example, I've done some research with Burning Glass, and I did some text mining. Maybe I'll say a little bit about that later, but text mining on 600,000 plus analytics job ads. So they have a massive database. What this shows, it's a time series, a little hard to read. In fact, it's a little bit ironic. This is not a great data visualization I'm showing you right now at the lead of this seminar, but we'll talk some more about why that might be. But this is time series data beginning in January 2010 and all the way up to July, this past July, 2020. And these are new job postings in analytics and data science. And you can see the trend. In 2007, Tom Davenport wrote Competing on Analytics, and really, in my opinion, got the analytics revolution sort of started, or at least making it more mainstream, along with Moneyball. But you can see the job ads. And what's interesting here recently, if you look to the far right, in March when COVID hit, you see that steep dive. What is remarkable to me is how that curve bounced back up and got on its trend again. And so in terms of job availability and a demand for analytics, we saw that dip when COVID hit in late spring, and then late spring. But to me, it's kind of remarkable how that has bounced back. This is just a little bit of data from LinkedIn. It's just recent data. So the dark blue is spring, which means I just did this last Friday. And the light blue is from fall, which was early September. And you can see on LinkedIn, we have an increase again in analytics and data science job postings on LinkedIn. So from a job or demand point of view, it's remarkable to me how resilient that demand has been, given all the uncertainty and the political situation, the recession, the COVID pandemic. And with regard to the recession, often we'll see demand for analytics go up in a recession, because as companies cut back, they want to do that in a smart way. So that's what right now, that's sort of immediately what I see going on in analytics. I did write an article with Tom Davenport that appeared this summer in Sloan Management Review Online. This is in July. And we looked at what companies were doing with data science and analytics during this pandemic time. And what we heard from these leaders that we interviewed was that, two things happened. Depending on what industry you're in, either your demand dropped almost to zero, or it shot through the roof. So if you're Procter & Gamble and you sell Charmin, all of a sudden you're trying to figure out how you can crank out as much Charmin as you possibly can and get it distributed. If you're Hanes brand, which is a local company here in Winston-Salem, your demand for apparel basically dropped to zero. And so how do you deal with that in either case? Well, a lot of these companies had sophisticated automated machine learning, and they had to hit the stop button, because all of a sudden the data that you use to feed those models was like nothing we'd ever seen before. And so what they turned to was more descriptive analytics. And that's what we want to talk about today, descriptive analytics, and in particular, data visualization. So I think it was interesting. We hear so much about artificial intelligence, automated machine learning, but when something dramatic like the pandemic hit, everyone hit the stop button and reverted back to simple reports and visualizations, just to try to figure out what was going on and what the next move should be. So like I did with analytics, I want to just give a definition. You can Google this and find a million definitions, but this is the definition I use: the use of graphical displays to explore, summarize, and present information and data. My co-authors of all my other textbooks and I are actually just finishing up a textbook in data visualization, a college textbook, which will come out in May. But our focus of our book is on both exploring and explaining with data visualization. And so you can think about a data analyst. The first thing they should do is kind of look at the data to get a feel for the data. That's the exploring side. What I'm going to focus on today is the explaining side. So how to use data visualization to present and influence effectively. And I'm going to use a lot, different examples, and I'll give some references at the end, by the way, that this talk relies on. So here's an example. This is actually from the back of an annual report for a School of Business, not Wake Forest, but some other school. And what you see here, this is undergraduate majors, percent of undergraduate majors by area. So accounting, econ, finance, the rest of these things you can major in at this university in the School of Business. And we see the percentages here. And there are real issues with this visualization from a best practice point of view. But what I'm going to do is I'm going to go through a series of slides. I might go back and forth, but I'm going to kind of be like your when you're getting your vision check kind of. I want you to think about, was the last slide better or worse than the current slide I'm going to show? So here's this pie chart. It's 3-dimensional. I just collapsed it down to 2 dimensions. So would you say it's more effective or least effective? I'm going to argue I can see what's going on here better. And in fact, that 3rd dimension adds absolutely nothing to the story here. You could argue that it's a little buzzy or it's cool, but if the idea is for the audience to glean the information in an effective and efficient way, that 3rd dimension should not be used. So I collapse it down to 2 dimensions. So there's a lesson. We'll get back, we'll try to summarize these lessons, but don't use higher dimensions. No matter what the data visualization software people show you, don't use dimensions higher than you need. So I collapse it to 2 dimensions. Now there's been a lot of science actually around our ineffectiveness as humans to distinguish angle and area as opposed to length, something simple like length. And so many data visualization experts, and I'm sort of in this camp, when you have a lot of slices like this, will say don't use a pie chart. Pie charts are ineffective unless they're very simple. Because if you look at this, it's hard to distinguish. You have the labels, but just looking at the slices, which is what you want somebody to be able to look at the slices. Some of them are indistinguishable, and some of them are in fact exact, but the only reason I know that is because of the labels. So there's this rule, I think most or many visualization experts would say is don't use a pie chart. Instead, use a bar or a column chart. So this is the same data. And notice something. There was no need for color when I went to a bar chart. Now you might love color. In fact, again, the data visualization software people give you all these glossy colors, but those colors, once I go to a bar chart, there's no need to use color because it's all about the labels and the length. Color can be a distraction. Too much color can be a distraction. And we'll talk more about color. But this isn't great either. I mean, for one thing, I'm going to need a neck brace to read those labels. They're slanted. So how about we turn this on its side? Okay, back up. What did I do there, by the way? There, I went from here to here. I kind of blitzed through that. I just sorted. All I did was sort. So I would argue if you're trying to find, say, the third best or third most popular major, it's a lot easier to do it with this chart than the previous one. But I'm still getting a neck brace, so I'm going to turn it on its side. So now I've sorted the percentages, turned the bar chart on its side. The column chart became a bar chart, really. And the labels, now if I want to find the third or fourth or fifth best, and even if I want to say find information systems, it's relatively easy to do. And I can see sort of where it ranks in the majors. And so, you know, if your goal for this data visualization was for a parent or a student to look at the chart and say, oh, I'm thinking about operations management. I wonder how popular that is within the School of Business. Now I can see that that's fourth. The major I'm interested in is fourth. It's 8%. I can see that the most popular major by far is marketing, then accounting, then finance. Looks like hospitality management's only 1%. Maybe the school's not that good in that major, so I don't want to take that. You can make all kind of inferences, but the point is, from a usability point of view, this is much more effective than that three-dimensional pie chart that we started with. So what did we learn so far? Don't use unnecessary dimensions. Pie charts are not good. You know, we could argue about that. That's a statement I'm going to run with, though. Usually replace a pie chart with a bar chart, especially if there are a lot of slices. And axis labels should be easy to read, and get rid of redundant information. So you don't want your chart to be too busy. And so let me go back and emphasize that again. So here, notice I have I have a y-axis that has percentages, but I also put the labels on the bars. So there's no need for the y-axis here. So when I turn it on its side, notice I got rid of that axis. It would have become a horizontal axis, but because I labeled these, that axis is not needed. And so I got rid of it. So we'll talk more about decluttering, but that's what I mean by get rid of redundant information. All right. So I want to say a little bit, get a little bit more scientific, but not too much. When you're trying to present something with a chart, your brain works in such a way that there are some things your brain will get you to notice without you even thinking about it. It's instantaneous. And so if you have an important message, you want to understand that, those kind of things that drive the brain, attention of the brain in a reflexive, just a reflex. You don't even have to think, it just happens. And so these are called preattentive attributes. And there are 4 of them here, 4 categories: form, color, spatial positioning, and movement. And form has to do with orientation, length. I'll show a picture in a minute. Color, we know we can highlight things with color. So I'm not going to say never use color, but I'm going to say use color with a purpose. Don't use color just because you did a graph in Excel and it threw all these crazy colors on it by default. Spatial positioning catches our attention, and then movement catches our attention. So again, these are called preattentive attributes, and they catch our attention without us even thinking or having to react. So here's what we mean by those. In the form section, I'll just look at a couple of these. If you look at length, we can really easily determine length, which is in the example that we just saw. Width, orientation, size. If you want to highlight something, make it bigger. Change the shape if you want to highlight something. Enclosure, we can use that for grouping and highlighting. Color, if you can see the dots there, just change the color of what you want to highlight. You can use intensity. I'll talk more about color. Position. These are all things that catch our attention without us thinking about it. So we can use those to drive our visualizations, to help drive the message, to drive our audience to focus on the chart in a particular spot of the chart even. And all of this is used in the design. This is a cute little thing that's on the internet. That in the lower left is where I found this. But I think, remember when we all used to fly? I actually haven't flown since March, but I am Delta loyal. I always fly Delta. So I'm a Delta points person. And that, what you see there is a typical Delta boarding pass if you still use a boarding pass. But what if we thought about that from a data visualization and preattentive attribute point of view? Someone on the web said, here's what a well-designed graphical boarding pass would look like. And let's just take one. We don't have to go through these a whole lot, but I like the one where it says, it shows the graph on the geography. You know how you get on a flight, you're always not quite sure. There's some chance until the pilot tells you where you're going to go that you might be actually going somewhere you don't want to go. Well, that picture shows me I'm going from New York to Seattle, and it's very easy to see. And so there's no confusion there. Likewise, the boarding pass shows you the seat, and there's a little graphic that shows you where you are inside the plane, which is great. And also distinguishes, I think, very clearly boarding time versus departure time. So well-designed graphical display uses a lot of preattentive attributes. In fact, the Seattle, the little geography there is motion, right? You're moving, you're leaving New York City and going to Seattle. So a lot of this is design. And I'm going to start going through some questions that people give around or sometimes uninformed about with regard to visualization. So these are bar charts. We've already seen bar charts, and people often ask, is it lying with statistics if I don't start the chart at 0? And the short answer is it depends. Lying's a strong word. Is it deceptive? Is it best practice or not? Here, what we have are average number of actually weekly hours of work in a main job, full-time employees 2013. It's by country. And this had to do with Germany. So you see Germany's highlighted, use of color, good use of color. But the axis starts, if you look down at the bottom, at 36 hours a week. And you're using a bar chart here where length has meaning. The length of the bar has meaning. And so if you actually change the axis, you get what's on the right. I would argue that what the right chart shows is actually there's not a lot of variation in countries, right? It looks very pronounced on the left, but it's not on the right. And I would say the right is more accurate in this case. It's across countries, it's across categories. By the way, this is, I won't call it out, but that's, you see the website, the source on the bottom right, there's a book by the same title out now that I highly recommend. It's not just about charts, but about data in general, about how to know when you're, when you need to have a heads up about is something accurate or not. So most people would argue for this kind of data, you should use a zero-based axis because you're using length intentionally across categories. Here, this is time series data, and we're kind of comparing two things over time with line charts. Less important. Most experts would say it's less important to start your axis because you're comparing these two things over time, and you're trying to look at the differences and how they change. This has to do with households and parental work. And if we saw, these two lines were together for a while and then they started deviating, that would tell us something. So it's not so important how high up on the graph it is. So, and in fact, if you start at 0, it might diminish your message here. So it's kind of a gray area, but it's not, you should be careful. Most people would now say, start your axis at 0. And I think that should be the default. But there are exceptions like this where you want to show a difference over time, where I think it's perfectly fine not to start your axis at 0. So some design lessons. Clearly label your axes, rotate the figure for clarity. We saw that in the first example. If you have a key, we actually haven't, well, in some sense, maybe the boarding pass was a little bit of a data dashboard, but if you need a key, make sure that that's clear. Start your axis at 0 with bar charts. Okay, in some cases, not to start your axis at 0, depending on the circumstance. So a little bit about avoid clutter. This is, I think, pretty easy to understand, and there's a wonderful website. Some of this I do blame on people trying to sell software where they show you all these glitzy things you can do, which in some cases might be good, depending on your audience and what you're trying to market or what your message is. But in general, if the point of your data visualization is some concrete message that you want to convey to your audience and have them process it as simply as possible, you're going to avoid a lot of clutter. We'll say a lot more about that. This is a real chart somebody tried to create. I think it has something to do with bananas. It's 3-dimensional. I have no idea. I can't really gauge anything because the dimensions kind of obscure everything. It just makes me hungry. If that was the intent, that's the only thing this chart does for me. There's a reference there, junk charts. If you want to be entertained, I'm going to show a few of them, but there are some good examples out there of junk charts and what not to do. So it's always instructive to see what not to do. We can avoid clutter, as I mentioned previously, by avoiding an axis. An axis is just clutter if we don't need it. So this is a little chart. This is a reference here that I'll show you at the end. One of my colleagues, Jeff Schaefer, collected trick-or-treaters at his house over these years. I haven't asked him for the updated data yet, but when I label with the number inside the column chart here, a couple of things. I'm avoiding clutter by not having a vertical axis. I put the labels on the bars. The length of the bars make very clear what's happening if I just want to glance at this. I have a title, number of trick-or-treaters by year. So there's no need to label the axis at the bottom year because it's in the title. And even if I didn't have it in the title, you probably would be able to figure out 2008, 9, 10, 11 were years. So we're trying to minimize the amount of clutter that's not value added on a chart. So you need to think about that. It is a design issue where the issue is avoid unnecessary clutter. Keep it as simple as possible. What we see here is at Jeff's house, he peaked in 2011. There's an upswing potentially. I don't know if a one uptick in 2014. I'll have to get back to you on that with when he updates the data. So avoid clutter. Simpler is better. Don't use higher dimensions. That was the banana chart again, and we've seen this before. And want to mention something. There's something called the data to ink ratio that, the best of my knowledge, was started by Tufte. He's a famous, probably the original famous person in data visualization. And Tufte talks about the data to ink ratio. And the bottom line is, he says, you want to get that to as close as possible to 1. So if there's ink on the page in your chart, it's because you're showing data. And so don't use data unless it's showing something meaningful from the data. So some more about color. So to some extent, I was saying don't use a lot of color when I showed you that original example where once I went to the bar chart, I didn't need color at all. So I don't want to give you the impression that color's bad. It's not. It's one of the preattentive attributes. But so color is very effective if you use it purposefully, and that's what we want to talk about. So just kind of to drive home the preattentive attribute, this is something from Jeff Schaefer again. How many 9s are here? Here's the question. How many 9s are there? Time's up. How many 9s are there? Boy, just looking at that, we kind of did what? We changed just the color. We didn't change the size of anything, but it looks like there are 13 9s there. I'll give you a harder problem next, but I'm going to use color. How many 9s are there? The answer is 1. If I didn't use color, how long would it take to figure that out? So you don't even have to think. Your eyes it pops, right? You immediately see those things that are in color versus gray. You still have to count here, and you have to rely that the person, whoever did this visualization, caught all the 9s, right? But color it's a preattentive attribute. It naturally draws you when there's a difference. It draws your attention to where you've used the color. So you can use color in different ways. Again, this reference will be at the end. Jeff Schaefer is the co-author on a book. I really like this book. It's called The Big Book of Dashboards. I really like it because not only does it give you best practices in data viz and dashboarding, but also has a ton of real examples in it. So this is from their text. Different ways you can use color. Sequentially, so that kind of shows intensity. Diverging, so you have some sort of midpoint and you can be high or low. That's a diverging use of color. Categorical, you can use it to highlight something, which is what we just saw with the 9s, and it can be an alert. I think I would probably bundle the last two together. Highlight and alert are kind of similar uses of color. So a couple of examples. This is we can talk about GIS, geographic maps. There are a lot of issues there too, but this is sequential use of color where darker is more intense. In this case, higher population. This is divergent use of color. Here what I have is a percent change in same store sales. The stores on the left and the months are up top. And so we can see, for example, if I go to, let's just look at, it's actually called Delhi. These are places in Cincinnati, Ohio. We see that same store sales are way behind early. And if we just move from left to right, it's got a little less severe as we move across the year. We see that Covington is always been above same store sales in the previous year. So we can look at this. We're using intensity and the fact that there's a midpoint. That's what divergent use of color is all about. Categorical use of color. So we use usually starker, different hues, different colors for different categories. This is from the Wall Street Journal. It shows you, it's probably a little bit dated now. I don't have the date there, but it shows you Nobel laureates, Nobel Prize winners on the faculty. You can see, and it's the reddish color is economics and the blue is everything else. So you see it, Harvard's way out in front, but Chicago does better in the category of economics than any other school. So you can quickly look at this. It's sorted by overall Nobel laureates, the length of the bar. And we could have put labels here, but then you have the issue of category sublabels. So I think it's good to still use the axis labels across the top here. But it's easy to see what's going on in the red. You could also sort on the red, but you had to, I would say this is probably the better visual. You can immediately see here, Harvard's out in front in the total Nobel laureates, Chicago's, the mecca of economics Nobel laureates. So good visualization there. The Wall Street Journal, there's actually another good reference that's something like the Wall Street Journal book of data visualization or something like that. It's a good short reference. But in general, the Wall Street Journal has excellent data viz. The use of color to pop. So this is the old example from the back of the School of Business annual report. So if I'm going to use that, this is the chart where we ended, but if I'm going to address the operations management faculty and say, look, we'd like to increase, we want to do better. We want a bigger share of the undergraduate majors. This shows very quickly that our department, operations management, is fourth or 8%. We're actually less than half of finance, which is right above us. So if we're going to move up in the rankings, we have a lot of work to do. We have to more than double our percentage, unless we take it from, take some up from those above us. But at any rate, specific use of color again, a preattentive attribute, it stands out, so your eyes are automatically drawn to that spot on the chart. So an interesting thing about color is we do have to be mindful that we have colorblind people. And so about 8% of men and only 0.5% of women suffer from color blindness. There are different types of color blindness. People talk about blue, yellow, red, green. I think red, green is the one that most people talk about. But if you do a chart with categories in Excel, what you'll notice is that the default, depending on how you have your Excel set up, typically the default will be blue and orange. And a reason for that is it is one of the best combinations to avoid people struggling, people who have color blindness struggling. And so you have to be mindful of that. Try to avoid blue and yellow, try to avoid red and green together when you're trying to distinguish things, because colorblind people could have difficulty with that. This is a chart on a time series chart that's from one of my publications that on the left talks about software and how it's changing over time. Its usage is changing over time. But on the right, and I apologize because it's not clear because it was on my iPhone, I took a picture of my chart, and there's this wonderful iPhone app called CVS Simulator, and it's Chromatic Vision Simulator. And you can put it on your phone, and you turn it on, and you can look at anything, and you'll see it like a colorblind person sees it. And so you can see it's really kind of tough to distinguish in this case between Python and SAS, because colors are hard to distinguish. Whereas if you're not colorblind, they're very easy to distinguish. They're red and green, and we can pick up on it. So this app shows you, can help you kind of make sure that you're not disadvantaging colorblind people in your data viz. It's kind of a cool thing to have on your phone. So use color purposefully, use color to draw attention, to distinguish categories, to show intensity. And most people would say avoid, when you're trying to distinguish, avoid the red-green combination. And I think people call that out, experts call that out, primarily because it's so natural to use green as positive and red as negative, or green as growth and red as losing something. So there's colors, there's kind of a natural interpretation of red and green, and so you have to be cognizant of the fact that you could be disadvantaging some of your audience. I'm going to jump back to some learning by some bad examples. The principles we've talked about. So remember, we started with a three-dimensional pie chart. This is an example. I don't know if it's still out there or not. I didn't search this morning, but InfoWorld. You would think of InfoWorld as a very technical website. This is top IT skills. So there's all kind of stuff wrong here, right? One thing is you really don't need that shadow down there, but that's okay. That doesn't bother me that much. Some people would say it's fine to kind of market what you're saying. But one thing that's problematic here is I can just glance at this thing. It's the pie chart itself looks like a hockey puck when it doesn't have to. It could be two-dimensional, but it doesn't take a whole lot of math skill to realize that adds up to a lot more than 100%. So why you'd ever use a pie chart when it's not, a breakdown of the total is beyond me. So it's bad. It's also a bad choice of a chart, which we'll talk about in a minute, a little bit at least. Another example, this is just, I don't know what that is. Whatever they're trying to show here, that's not going to be effective. It's kind of like the banana chart. I mean, these things look like dried up pasta angled, or I don't know what they look like, but you can't really tell anything from that picture other than it looks like a train wreck. Too much color, too many labels. At least up on the one on the upper left, it's sorted, but there's too many categories here. You can't make any sense of anything other than a total. And so really, two really very, very bad visualizations. They might do a good job of catching your eye, but any message that was supposed to be conveyed is lost. So we could do a whole seminar on choosing a chart type. In our textbook, our college textbook, we have a whole chapter on this. We have a whole chapter on color. So all of these things we could spend a lot more time on. But the chart you choose should have to do with what your goal is and who the audience is. So who's your audience and what's the message you want to convey? There are tons of charts out there. There's not enough time in today's seminar to go through all the different types of charts, but here's a couple of types of charts that can be used to facilitate different messages. So are you trying to show composition? Are you trying to compare values? Are you trying to show distribution or uncertainty? Are you trying to show relationships between two or more things? They lead to certain types of chart choices. And there is this graphic, this is from, you can see my source at the bottom, but this particular chart, some data visualization experts disagree with this, but it's a chart of how to choose charts. And it's out there. You Google it, you can find it. But at least it tries to bring some structure to your thought process. So I won't deep dive into this, but it's kind of like a prescriptive chart that says, if you're trying to do this, if your focus is this, here's some kind of charts that might be useful. Obviously, if you have time series data, a line chart is usually a good choice. If you have categories, typically a bar chart or a column chart when you're trying to compare categories is usually a good choice. If you're trying to look at the relationship between two variables, a scatter plot or scatter chart is typically useful. So anyway, I'll let you spend more time on that as you see fit. A couple of examples. This is again from the Wall Street Journal. It's a stacked bar chart. It shows me, this is capacity, new power generation capacity worldwide by energy source. This shows me the green renewables increasing. It's the trade-off with others. I can see nuclear actually is increasing. Oil seems to be decreasing, and gas, is somewhere bouncing around a little bit. And coal, same with coal. There's some down years. So the real thing this drives home, I think, is renewables. I would argue if your real message is that renewables is going up as a percentage, I would have just done a simple column chart with just the green part. At any rate, it's a stacked bar chart. A lot of people use those. It's often clever, depending on your audience, right? If you're talking to salespeople or whatever, add a target line. Because if I just put these, this is some kind of sales bananas, apples, grapes, and oranges, if I don't have a target where we expect the sales of these to be, I lose some perspective. It's nice, I can immediately see bananas as number one, apples, grapes, oranges, but putting that target there tells a little bit different story, that only apples and bananas have met the target of 16. That's very useful. I include this chart just because a lot of people don't know about it, but I think it's kind of cool. So on the left, you have a dot plot. It has to do with, this is a distribution of a final exam score. A dot is a student's score. And so if things are really dense, you can't really see what's going on. There's a thing called in the sense that dots are on top of each other. So there's this thing called a jitter chart. And if you apply jitter, which randomly, it gives an x-axis value to each final exam score, but it's random, so it scatters things. And you can still see where the scores are distributed. So it kind of brings a little clarity to, this is a case where adding a dimension brings some clarity to the distribution. Kind of an interesting chart. I threw this in at the last minute. The Economist, like the Wall Street Journal, has some outstanding, they have departments of data viz that are really good. This one I thought was kind of interesting. I'm not sure how I feel about it, but I thought it was interesting. So this is, let's see, earnings 1 year after graduation by college major. And it has college selectivity. So let's start in the upper left. I'm not sure I would have done it this way. So, you can just think about this. These are scatter plots, but they fit lines to them or curves. That's fine. I don't have a problem with that at all. Just kind of, directing your eye to the trend. But the x-axis here, the horizontal axis, is admissions rate, percentage. The vertical axis is salary, earnings. And it's interesting that the horizontal axis is reversed, right? So let's take a look at business and economics. The interpretation here is for less selective schools on the left, salaries are lower than at more selective schools on the right. So if it's harder to get into Harvard and MIT and Wake Forest, then that's more selective, it's more expensive, and earnings are supposedly higher. So, but I struggle a little bit because the axis is reversed. So, sometimes there are no hard, fast rules, but you have to really pay attention to the axes, I guess, is maybe why I put this in here. I know we're getting close to time, so I just want to do a quick sidebar. So this isn't so much about the visualization. We're going to use the pie chart as an example. This is more about presenting, so slide construction. So we can critique this now that we've had a little webinar here. We don't like the pie chart. I don't like the fact that the pie chart is a little bit puffy. So there's that dimension there that adds nothing. It's not as bad as a full-blown hockey puck, but I'm not sure why we need a puffiness here. But I want to emphasize something else with this example. Notice what I've put on my slide as the slide title: hours spent on various activities. And then there's a chart title: time use on average workday for employed persons ages 25 to 54 with children. And the sources at the bottom. If I'm presenting this, and I throw this slide up, people's attention are drawn to the unacceptable pie chart, and they're not going to read that title. But the title adds nothing: hours spent on various activities. But if I'm going to use this chart, what I could put as the title of the chart or of the slide is the message I want people to get from my chart. So you need to put your message here because people aren't listening. They're not listening, they're looking at your chart. And then when they're finished looking at the chart, you've already said what you want to say, and they haven't picked up on that. So maybe this is better. on average in a typical workday, more time is spent on work-related issues than on sleep. And I would argue, okay, now I have a message in the title of my chart or my slide, but I would still argue that, you don't want to use that pie chart. If what we're really trying to do is compare work to sleep, let's highlight those and have with the message also there. I can look at the chart now and say, wow, I know that the thing we spend most time on is work and related activities, and sleep is second to that, but we actually spend more time working than sleeping. And it's also there in the message. So it's like the title's like a backup to what you hope they glean from the graph, actually. Okay, so summary, data viz is important. You probably already thought that, or you wouldn't be here. I hope you got some perhaps new information about preattentive attributes, and those are important because they draw the audience's attention to where you want that attention. Try to avoid avoid clutter and use color with purpose. So don't get seduced by overuse of color. It looks shiny, but actually could be hurting the ability of the audience to get your true message. Couple of references. The one on the left is an article that I did with colleagues Mike Fry and Jeff Schaefer in this journal called Interfaces in 2017. The journal title has changed now. It's called the Informed Journal on Applied Analytics. But if you Google this, you'll see this. It's a practitioner's guide to best practices. There's some more things in this article than what I got through today. And the one on the right is Jeff Schaefer's book that I referenced several times and took some figures from in this presentation. I actually did a review of that, and I think it's a great book. So with that, a little bit of what's going on with our exec ed folks, Carrie and Whitney, what we have coming up. We're doing a 3-course sequence: descriptive, predictive, and prescriptive analytics coming up soon. And each course, you can take it as standalone. And I'll say a little bit more. If you take all 3 courses, you have the opportunity to get a certificate in analytics from Wake Forest Exec Ed. So each of these standalone courses they're over 2 days. They're virtual, obviously, like this seminar. March 9th and 10th, my colleague Jordan Goldmeyer is going to do descriptive analytics. And so he's going to focus on data visualization, a lot about managing data, and everything inside descriptive analytics and how that's useful. So it's more of a deep dive into some of the things we talked about, over 2 days, 8 to 12 each day. My colleague Tanya Balin, who is several years running, has been Teacher of the Year in our master's program in analytics. She's outstanding. Used to work for SAS, is now full-time with us. Tanya's going to talk about predictive analytics, so forecasting and figuring out the relationships in a quantitative way that exists between variables of interest. Those kinds of questions, very applied. All these 3 courses are going to be very applied, very boots on the ground, solving business problems with these techniques. So that's April 6 and 7. I'm going to do prescriptive analytics and optimization later in April. This will all be in Excel, but what distinguishes prescriptive analytics from the other 2 types is you're building more of a decision model. An example might be portfolio optimization in finance. What mixture of stocks, bonds should I have? Which stocks should I have in my portfolio? There's an optimization model that will help you do that. So that's the kind of thing we're going to talk about in the prescriptive analytics class. And so you can take each one of those if you're interested. You can take standalone. But we're also offering a certificate if you take all 3 of those courses, and at the end, what we'll ask you to do to get the certificate is you'll write up what you see here. Essentially, you're going to apply some of what you learned to a real problem that you have access to, and then you'll do the work. and then submit it, and it'll be overseen by me and possibly a couple of other of my analytics colleagues at Wake Forest, and then you'll be awarded a certificate through our exec ed group. We do have a couple of other informational webinars coming up on the 26th and the 4th of February that are similar to this, that are no cost. There's more available on our website about those. So with that, I think, Carrie, we are going to take some questions with our remaining time. Looks like we have roughly 10 minutes left.
Yep.
And I stopped sharing. Hopefully you stopped seeing my slides, and now we're back in picture mode. So do you have questions? Any questions? I'm happy to take questions now.
Great. Thanks, Jeff. Great presentation. We do have a couple of questions that have come in.
Whoops.
Battery 50%.
Sorry, Carrie, I kicked out.
I still got you.
All right, you're back now. I can hear you. I hope you didn't say too much.
Hey, Jeff, we've got a couple of questions here. It says, in your first one, in your experience, what is the biggest challenge faced in presenting data to senior leadership, really in the context of data visualization?
Yeah, so I think the biggest thing, which I alluded to previously, is people who haven't thought much about or studied data visualization, even at a very cursory level, get seduced by the multi-dimension and the overuse of color, and then the message gets lost or is less effective. So, you know, a lot of that stuff is fine if you're doing more of an infographic where, you know, you use different types of figures and all that, and that's more of a marketing kind of thing. But if you're trying to drive home a message, which is what you're typically doing if you're talking to executives or an audience, you know, that's come for a specific purpose, it's a little bit painful at times, but simpler is almost always better. And just make sure that you don't clutter things up, but you label things as clearly as possible, and you use only as much labeling as you need. So, you know, the real message is simpler is better. Choose the right type of chart. Don't overuse color. All those things we talked about, when you bundle them together, you can get trapped by the software. A lot of the defaults will trap you into those more elaborate visualizations that really aren't very effective. By the way, you know, we talk about software. There's Power BI, there's Tableau, there's Excel. Excel is pretty good. Excel has a recommended charts function. It's not always what I would do, but it's not bad in guiding you towards a particular type of chart. But you do almost always have to declutter, you know, the default charts, in my opinion, in a lot of these software packages.
Thanks, Jeff. Here's another question. I find this one quite interesting. Look forward to your thoughts. But what is the difference between a data scientist and data analyst?
Great.
Or is there one?
Yeah, if you get 25 academics like me together, you might get 25 different answers. But I've studied this a lot. I've studied job ads. And so let me say, I mentioned this a little bit, I think, at the front end. I believe there's a real difference between data science and analytics, okay? Data science is more data centric. It's a cross between computer science and statistics. And then analytics is more management science and statistics with some data management, but it's more problem focused, okay? So you said data analyst. Data analyst is a little bit of a hybrid in the sense that the fact that data, essentially it takes analytics and combines it with data in the title. And so it's a little bit, it's somewhere between what I just said. It's maybe a little more data manipulation, data cleansing centric, but it has still a focus on analysis, right? Problem solving. Maybe this is humorous, I don't know. What drives me crazy, it's a pet peeve of mine, is when people say data analytics. And my response is always, who's doing analytics without data? Why do you even use that term data analytics? It's analytics. All of analytics uses data. So I like to distinguish between analytics and data science, but there are so many titles out there that it's really confusing out in the workplace. I interviewed a Fortune 500 executive who oversees a large data science / analytics group. And he said, look, we just use data science. We label everybody who's doing analytics or data science or any kind of analysis, higher level analysis, we label them data science just because that's what they want to be called, because I think they're going to make more money with that title. So there's a lot of confusion out there. Hopefully I shed a little light on that question.
Good. Jeff, next question. And I'll just expand on it. So basically, as you began the presentation, you said we are clearly in the age of data. Social media and news channels are flooded with graphs and charts and many data visualizations. How do you think this has impacted how people how people receive and believe information?
Yeah, excellent question. It's a big problem, right? Because what there's such a reliance on data now in all of society, but I'll maybe focus on one aspect. I'm writing another book for general consumption, and it's essentially on this theme of this question. So how is data and how we consume it impacting everyday life? Think about the media. So I used some examples from the Wall Street Journal, The Economist, USA Today, all the websites out there, they all use charts and graphs. And it's very easy to get misled with charts and graphs. So I pointed you previously, if you Google Calling Bullshit is the name of the book and the website. It's a course actually at the University of Washington. There's a lot there about you can mislead your audience unintentionally or intentionally. In either case, you've misled your audience, right? So we can kind of separate those two things, the intentional misleading of people with charts and graphs versus the unintentional misleading. And there are a lot of really good examples out there at that website. I would recommend you go there. But what my take is, I guess my summary answer would be, we need to educate people, right? So we need to educate people how to be intelligent consumers of data, and particularly charts and graphs and how they're presented. And it's sort of like the buyer beware, you know, some people are using intentional deception, and you better be able to pick up on that right away. So I think one of my soapbox things lately has been, I think every college student should take a course in data visualization, just from that point of view. So they can be, they've turned out to be great data visualizers, but to be able to consume data, numerical data, even text data, in an intelligent way is really, really becoming more important in my opinion. So it was a little long-winded, but I think every college student should have a course in what we just talked about. Should be required, just like English, lit, whatever.
Spoken from a man with passion for analytics. So. Jeff, we're at the top of the hour. You know, thanks for your leadership of today's webinar. For those who may not be aware, Wake Forest Executive Education provides both open enrollment and programs customized for personal and professional development. The information and content that Jeff just presented is part of a broader certificate in analytics for analysts beginning in early March, as he's laid out. For those of you who may be interested, a link to this program along with a recording to today's session will also be provided to attendees in follow-up. Just want to thank everybody for joining us today. Please stay safe and healthy. Have a good one.
Thanks, everyone.